Dan York was going to take it. I am just looking where he is. Hey, good afternoon, everyone. So welcome to the first meeting for TIPTOP Working Group. I just want to remind everybody that the meeting is recorded. And please note well that you're participating in IETF, and we follow the policies of IETF and their processes. And we are here to have technical discussions, and we keep it civil. And note well, very well, is please make sure that we keep ourselves to technical discussions. And if anyone feels he's harassed for whatever reason, please bring it up. And now, for in-person participants, this is just the meeting tips that we have. I'm pretty sure by Thursday you know all this by heart now. This is the resources for IETF 122 Bangkok as well. And here it is. So before we get started, I would invite Eric, our AD, to say a few words.
So as is always the first working group meeting, that's always interesting. And I would love first to thank the chair accepting to this challenging. We have Padma, the routing chair, and Zed, the transport chair. And with the audience, I hope that we will go through. Sometimes the first meeting in a working group is very important because it's launch us to the right track. So I wish you an excellent and fruitful meeting.
Okay, thanks, Eric. So just to get started, because it's our very first meeting, I'm just going to remind a little bit and go a little bit of our charter to make sure that we. Yes. Yeah.
So thanks, Dan, for taking the note, but I'd love to have a second, so that if there is anybody else, they can volunteer for taking some notes, helping Dan, filling up. Anybody? Okay, we got MRC. Thank you.
All right, thanks for that, Zed. As this is our first meeting ever, we want to actually go a little bit over our charter just to remind people who haven't had a chance to see it first on what we will be working on. So the first of items is actually understanding what kind of use case we're actually taking care of and what is in scope and not in scope. From that derive the key characteristics of those use cases and the requirements. Part of that in parallel, what we're doing, and we're going to have another presentation about that one as well. We'll be looking at the use cases. The second presentation is also going to be about the IP network architecture. Just a reminder that we are looking at how we can adapt IP for these very long communications, long delay communications. And then we are also looking, there's a third presentation today where we're going to be looking at quick, and Mark is going to actually talk about this. And the last one is considerations for deployment of DNS. Now, more from our charter, we welcome discussions from key stakeholders, such as other working groups, and I'm just not going to repeat everything here, but we really welcome to have more participants from everywhere so that they might have different point of views, and that would be interesting. One thing we do want to remind everyone is that we want to reuse as much as possible existing protocols, and TIPTOP will be collaborating with all the protocols and working groups that actually may have any kind of interaction with us. So that can be time-variant routing, quick, TLS, DNS ops, and DTN. So we will actually include copying them and in our calls for adoption, as well as lost calls. Alternatively, if there is any agreement that the work has to be done here, it will be done here. What is out of scope, specifically bundle protocol and IP networking for LEOs and MEOs, as well as GEOs, are out of scope in this group. And as this is a very, well, we're newly minted, so we don't have working group documents yet. But here's the list of current non-working group documents that haven't been adopted yet. So you will see some of them are already on the agenda today. Some of them aren't. And we're going to have those 3 presentations, plus, if time permits, some others. There is one which is on agenda, but we don't have a working group document. We don't have a document yet, a draft. That will be the key exchange customization. And if time permits, the co-op. Here's the agenda. And I think that before we start the presentation, Zed, anything you want to add?
No, I think it looks good. Let's go ahead. We have this proposed thing that we'll discuss later on.
Okay, then the very first presentation is by Wesley Eddy over their use cases, key characteristics, and requirements. So, Eddy, you're going to be next.
Okay, great. Am I coming through okay? Can you hear me?
Yes, yes, we can hear you.
Okay, great. I think I also yesterday submitted some updated charts, so they may not be the latest in the tracker. Do you want me to be sharing screen, or are you going to put the charts up? Okay, so hi, I'm Wesley Eddy, and even though it's 4 o'clock in the morning where I am, I'm happy to talk to you about this draft today. Mark Blanchet and Marshall Eubanks and I have been working on this use cases and requirements document, and we wanted to make sure, first of all, that, going too far. We wanted to make sure, first of all, that you could find a copy of the document, because this is the first working group meeting, and it's a pretty important document for the working group to set the context for what we're doing. And we'd like to ask, I guess, that people if you haven't already, go look at the document. I think you'll find it pretty easy to read, and it's not very long. In fact, we'll probably need to flesh out some of the requirements as time goes on, but the idea early on is at least to get the outline nailed down and make sure we're covering the right content and going into the right types of things. So this is directly targeted at the working group charter item for the key characteristics, use cases, and requirements. There's also a architecture draft, and as you can imagine, there's a lot of related topics between the two because the requirements and use cases drive architecture. So Tony's actually talked about that later, so don't maybe get too excited by some of the things in this one. And there may be some movement of material between the two drafts over time. So this is why I had updated charts. There's actually a new table of contents because earlier this week we updated the document based on comments we had been receiving and some discussions amongst the editors on the side. It mostly looks like what's shown on the chart still, but there are some small changes. I think we added maybe more requirements. The idea, though, is to first talk about sort of the IP and deep space overall drivers, and then get into the characteristics of space missions and space mission application needs, and use those to develop the requirements set that's in the fourth section. And the idea is actually, even though there are a lot of different mission types that are valid, we would focus on the common facets between them and make points about the specific differences that exist within the total set. So that's what I mean here by challenges. We're trying to have a general document that's approachable for people that aren't experienced in interplanetary networking. And in fact, when it comes to IP in deep space, no one is that experienced because it hasn't been a common thing yet. So we want to have an approachable document, and we know that space missions vary a lot. There's a lot of drivers for uniqueness in any individual mission. So we're trying to be clear about those, but find the common ground and make sure that the requirements that we're writing cover that well. Also, we'll be able to accommodate distinctions that would be likely to be needed for maybe individual use cases. So what I mean by that is that there are obviously some differences between the Moon and Mars. There are huge differences between crewed missions with humans aboard and uncrewed robotic missions. And there are other distinctions you could make between science missions at Lagrange points and things happening on the surfaces of different bodies. We might also call out a wide range of device capabilities. There are spacecraft of many different sizes now. You could also maybe think about, in the mailing list, there's been discussion about asteroids that came up in the last day and whether those should be in scope, and there could be some differences related to asteroids versus the larger planetary bodies. So to give an example of the kinds of things we're trying to describe in the internet draft, thinking about the lunar case, which we can agree is not technically deep space, but we wanted to include it anyways at the BOF as when it was discussed. So the the case of the moon is in some ways more similar to terrestrial internet than the other use cases, and yet still a bit challenging. So it's growing towards our ultimate goals of deep space IP. The moon may actually have pretty rich connectivity options with surface wireless networks, relay networks in orbit around the moon, and a number of different links direct with the Earth from different providers. So nodes on the moon could actually have quite a good connectivity and a number of different options even simultaneously. The main difference with terrestrial internet is that the round trip times will be multiple seconds at least, and there could be periods of disconnections depending on where operations are occurring and what the priorities and loading of the different providers are. Mars, of course, will have much longer round trip times than the moon, and I guess initially we would have potentially more human missions planned for the moon at the moment than for Mars. But my next chart on Mars, so we do plan to at the moment send human missions to Mars, and that looks a lot less certain at the moment than in terms of the networking architecture than what has been getting fleshed out for the moon. Definitely delay is one of the biggest differences, but there's also just much less experience in general at Mars. The number of routing opportunities is probably going to be less. There's certainly more challenge in doing direct with Earth communications from Mars due to the distances. And the disconnection periods could last quite a bit longer compared to some of the other settings that we've been including in the use cases like Lagrange points or the moon. That said, there are a lot of similarities between Mars and the other use cases we've been looking at. All of the use cases have generally the same types of application data flows and might use similar application protocols. So there's a more fleshed out list in the actual draft I would encourage you to look at. But the things that space mission applications need to do, such as commanding and telemetry, return of science data, messaging between mission elements, those are all consistent no matter where the missions are operating. They're pretty much the similar set of applications, and their needs are similar. Differences with crewed missions, though, include doing more voice and video oriented to human aspects. In terms of security, there's a lot of commonality as well. And one thing I think is also very worth pointing out is that a stated goal of the US, at least, is to reuse many of the systems that have been developed for the lunar missions to bring those to Mars and reuse as much as possible. So I think that actually the scope of the working group doing Moon and Mars very clearly in the charter, it works quite well. So we've actually updated the requirements areas here a little bit since we have a newer version of the draft since earlier this week. We've focused on the differences or gaps between the common terrestrial usage of IP and the IP stack protocols versus deep space use cases. And so some of the sort of driving requirements are the store and forward, maybe needing notion of time, signaling and exchanges that are reasonable to take place, the low bandwidth that might be generally available, And also asymmetry and unidirectional links are needing to be supported. There are some addressing and routing requirements we started to discuss. And beyond the list on the chart, we've also added transport and some security considerations into the document. And all of these will likely need to be fleshed out a bit more, but we're trying to get at least the early thoughts into a document and be there for information and discussion in the working group. I know we don't have a ton of time to discuss these in depth today, but goal is really to get eyeballs on the draft and have exchanges on the mailing list. A lot of these things I have as planned additions, we've actually already made in an update. And so actually have a different set of next steps in my real charts, so that there is good feedback coming in on the mailing list, and we've been incorporating that gradually. We definitely will plan, at least for a couple of the requirements, to expand the discussion a bit more. And what we'd like to ask is that people will check out the document, read it, and give us feedback on the mailing list so that we can ask for working group adoption before too long. And that's all I've got with, I guess, 2.5 minutes or so left. Are there any questions? I'd be happy to discuss. Maybe we want to talk about asteroids, since that's already come up on the mailing list. Personally, I would say I think asteroids would be fine to include in the scope. I think I agree with Jorge's latest message. I thought said it well.
It seems like we don't have any queue right now. We do? Just, yeah, Britta.
Thank you for the presentation. So we had discussed on the mailing list the security aspects of this and the general approach. Of course, we're going to have to talk about that later in the session, so I don't want to discuss it now, but that is obviously a consideration to going ahead with this.
Yeah, and what we have is probably preliminary there, and it would be very welcome to get more contributions or people's thoughts there.
There is one comment in the chat. It says like, what would be also important to characterize is packet loss or bit error rates for the use cases.
Yeah, that's a good thing we should discuss, because I think you could make a bad assumption maybe. So the thought is probably that typically because of the long distances and limited radio link power, that there would be low bit error rates or high bit error rates and packet loss rates. That may not be the case, though. Usually pretty strong FEC coding is used in the physical layer, and there are generally high enough link margins when operating to prevent high amounts of packet loss from occurring. But this is a good thing to discuss in the draft and make sure that the needs and the assumptions are clear. So I agree, that's a good comment.
Thank you, Wes. I actually have one question that I'd like to ask. Like, when we are defining the requirements, does it matter, or are we making a difference if machines are communicating or humans are communicating? Because I mean, you have the crew missions, crewless missions, and it will matter, right?
Yeah, we have to accommodate both cases. I think in the draft so far, we were just trying to draw the distinctions because, say, for instance, typically for a human mission, we would often, at least historically, want to maintain continuous contact and have great coverage. Whereas for a robotic mission, it might go quite a long time without receiving communication service sometimes. Might just receive periodic short checks. And so additionally, a human service might have more redundancy built in with primary and backup coverage, whereas the robotic missions might not have that kind of redundancy.
Hey, Wesley, I also had a question. As you mentioned earlier that we have commanding telemetry and different types of, I haven't seen in the list here about classification of traffic, but I think really you will need to add that at one point or another.
That sounds good, yeah. I see Jorge's comment also about the whether the use cases match LNIS requirements. So I think that there hasn't been any conscious effort to necessarily align those, although I don't think there would be any friction between them either. So that's something we could probably follow up together offline, Jorge.
Okay, last question from Rick.
Padma, it's actually a response to your question about traffic classification. Surely if we're using IP, we can use all the great traffic classification frameworks we've got built for IP, rather than inventing a special space traffic classification mechanism.
Yeah, that was my assumption, is that's what she meant.
Okay, so next will be Tony.
Hi, I'm Tony Lee. I have extensive experience deploying IP on one planet. And next slide, please. All right, so our problem statement. We're trying to make IP work. And in the interplanetary case, we've got some really, really long delays. In the worst case, we're talking 4 to 20 minutes. And we've got link outages for hours and days. We're used to link outages. Submarine cables go out for a month. That's not news, but these are planned. So how do we make this work? We have a whole lot of things that are non-goals. We are not trying to boil the ocean. Not everything that you know and love on the internet will work well. There will be no web surfing from effective long distances. Just not going to work. Your interactive terminal access, terminal emulation is not going to work. FaceTime, right out. Basically anything interactive, not happening. Anything that's going to have load, delay, or jitter requirements, not helpful. And basically anything arbitrary, any to any, we are not trying to solve. Okay? If you want kitty pictures, take them with you. What are we trying to do? Mostly what we're trying to focus on are bulk operations. File transfer, email, data streaming, that's got to happen. We need control and management planes for spacecraft. All relatively straightforward. We have relays that are going to be in place. They're going to have IP stacks that we can tweak. That's fine. And in the normal parlance of IETF, we are very much treating this as, quote, a limited domain. Okay. So what do we have to do in the network layer? Well, the forwarding plane, those link outages, we actually want to do something very, very strange. Normally, when a router gets a packet for a link that is out, we just toss it on the floor. Yay. In this case, we don't. We want to actually store things. And so we want to have some extremely deep buffers. And we're talking, possibly megabytes or even gigabytes of buffering. We also may want to be able to handle rerouting, possibly after buffering. We've had this link go out for many hours, and it's supposed to come up, and guess what? For whatever reason, it didn't. What do? We don't want to ditch all this traffic. We've already hauled it 14 million miles. We'd like to actually forward it. Suppose we have another low bandwidth path, and we just reroute that traffic instead. That's something we should be able to do. We have to have an addressing scheme. I'm here to strongly suggest, and I've done this for 30 years, say it again, hierarchical addressing is your friend. It will simplify life. Very much would like to see planetary prefixes. Yes, the IETF has spent umpteen cycles arguing about geographic aggregation. Here's a case where I would strongly suggest that geographic aggregation will help us greatly with routing efficiency. I do not want us to see something that looks like the IPv4 routing swamp in space. If you can imagine, say, the moon or Mars with 1,000 lands on it someday soon, I don't want to see us carrying around 1,000 prefixes. It just makes no sense. Let's figure out a better way, and we know how. How do we deal with routing? Mostly routing is pretty straightforward. We know how to deal with routing on a very limited basis for small planets, and that's not an issue. The only interesting things are these long-haul links that go out every so often. What do we do about those? Well, it looks very much like doing something that's scheduled and static is not such a difficult thing to do. It's certainly not part of what we do today, but it's a shell script, guys. It's not that hard. Now, the transport layer is a lot more fun. UDP, not much to be done there. It just works. If you can handle the delays and the losses, it's fine. But if you're going to do connection-oriented, well, we know TCP is pretty much a non-starter, but we can do things with Quick. So what we can do is to tweak parameters to deal with those long delays. And Mark will talk to us about that in the next talk. We can also make use of multiple streams. We can have pre-opened connections. All of this seems to suggest that Quick is viable for what we're trying to do. We can also do HTTP if you don't like to mess around. Obviously, we're not doing this for web traffic, generic web traffic. We're talking curl transfers, REST APIs. So that's pretty straightforward. Obviously, we might need to make some tweaks to handle the timeouts, but nothing major there. DNS. So there's some pretty obvious things we can do. Again, because we are operating in a limited domain, we are not expecting to get to CNN from Mars. Okay, that's not the issue. We only need to access a very limited set of names, and they're probably not going to change all that often anyway. So we can make very good use of limiting what we are carrying around in resolvers. We can pre-populate some caching servers. Okay, it's not that hard, and these names are not going to change that frequently. So this doesn't seem like that big a deal. Yes, I'm well aware other people are making proposals about just carrying the domain name around and resolving it on the other end. Yeah, you could do that. I don't think that's really necessary for now in this limited domain. All right. Management plane. Very straightforward. We've got netconf and restconf. This is normal stuff. Again, we would have to carry this over space profiled quick, but this is really straightforward. You got a new config you want to push, just push it. That's about it. Any questions?
Martin Duke, Google. Thanks for the presentation. I appreciate your scope management on like non-goals and so on, but presumably this architecture supports doing real-time stuff on within a particular celestial body.
Real-time stuff within a particular, shall we say, distance?
Sure.
Okay. Yeah, I mean, if you want to, run FaceTime on the moon from moon to moon, that's fine.
Yeah.
No
Okay.
big deal.
I don't understand the scope of your document. So is it specifically about the Earth to wherever link, or is it
It's
kind of
about
the whole thing?
It's about handling the long delay. Okay, that's
Okay.
where the interest is.
Alrighty, thank you.
Yeah, I guess I I have some questions about the long delay and whether and or when it strays into DTN, but I need to read the architecture document first. But I wanted to ask you about the addressing. Is there some reason that the regular RIR style scheme wouldn't just work, where we would have an RIR per sort of area, and then we might not have one prefix per planet, but we would just have still maybe a very small number?
I'd like to defer this question to my next talk if I get a chance to talk about it.
Thank you.
Hi, Tony. Thank you. Quick question. When you specified your non-goals, you said SSH and Telnet is right out because it's interactive. RESTconf and NetConf are interactive. So what's the proposal to use? So you look at the use cases and the architecture document are talking about standard management protocols, but you're now saying that SSH isn't a goal, and I'm a bit confused about that lack of clarity.
NetConf, the way I've used it is, well, it does not need to be interactive.
Okay.
You can have a controller that bundles up a config and takes up whatever you're going to do and ships it off in whatever form.
Okay. So there might be need to some profiling of that RPC to ship it, because
Yes,
that's
absolutely. But
yeah,
I mean, this is not rocket science.
okay.
Any other questions?
Hello, Brian Trammell, space reliability enthusiast. Thanks a lot for the document. The thing that kind of made me go, ooh, was like sort of the last thing you said about, oh, it's just RESTconf, it's just NetConf, we're just going to push it and go. Is there a need to have operational considerations in scope for the backup for some of these deployments for you Zorch the config might be a recovery mission? Or are we just sort of assuming that is rocket science and the rocket scientists will handle it?
Backup configuration is a solved problem in lots of routers. I assume we can do the same thing here.
Okay. Maybe a line in the doc that says that would have made my ears not pick up. Thanks.
Certainly doable. Thank you.
Maybe I can comment on this. Is having a backup is going to be extremely expensive, and that might be one of the reasons why it might be difficult to do it.
No, I'm not talking about backup. I'm talking about backup configuration, right? Like a known recovery, like the fact that when you're pushing a config here, if things go very wrong, it's different than you have to drive to a data center, right?
Exactly.
We do that routinely for satellites. They actually have a backup configuration always.
There are routers that will take a config, and if you do not interact with it in a set time frame, it will back out the config and revert to the previous config for exactly these reasons.
Scott Burley for IPN Group. Just one question is, when you say limited domain, can you say something about the scope of that domain, that limited domain? How limited?
That's up to the agencies. The way that the IETF uses it, basically, it is the domain specified by the operator. And normally in IETF, that means a single ISP. We can certainly have a limited domain where there are multiple agencies agreeing on what the boundaries of that domain are.
Thank you.
Hi, Prince Ezekiel. Do you have considerations for things like multi-homing, multi-pathing, and dynamic addressing in this kind of scheme?
I really couldn't hear that. I think you asked about multi-pathing and addressing.
And multi-homing, sorry.
And multi-homing.
Yeah.
Multi-homing is a topic that the IETF has been discussing for 30 years and managed to get wrong. If you'd like me to go on at length about ILNP, I would be happy to. But until we revisit that discussion, we're stuck.
Rick, with DTN chair hat on, there are a number of drafts tackling the exact problem of backup configurations reacting to failure when you can't have a direct link back to your master management system in the working group, DTN working group, and currently being reviewed by NetMod. So some of the architectural considerations, we could consider sharing that work.
Any other questions?
Hello, Michael from Huawei. I have a question about, is there any practice for LEO? Doesn't need any significant change and advanced to current routing protocol could suitable for the real network of satellite. Even it have very high frequency, predictable and unpredictable failures and link down.
I'd like to refer you to the charter slide. LEO discussions are out of topic for this working group. And if you want to see what I think about LEO's situations, please see RFC 9717.
Okay, thank you.
Last chance. Going, gone. Thank you.
Thanks, Tony.
Mark, you should have control of the slides.
Yes. Hello, good afternoon, morning for me. I'm going to talk about the quick profile. I was planning to also provide simulation results updated from the informal meetings we had since a year, but given lack of time, we'll defer this to another time. So the sad consequences is that, I could have shown the results of simulations in terms of the actual content of the presentation, but that would be for another time. IP in space have some transport considerations that are already been, talked about, such as, for example, minimizing handshakes, expecting long delays, provide reliable delivery of data end-to-end, and provide end-to-end security. transport doesn't see intermittence in the sense that it only sees large variations of delays because of intermittence. That's a key thing here is IP is taking care of the intermittent side by, as described by Tony, deep buffers and rerouting as needed. Transport is just see large variations of delays. Quick was studied. What is being discussed may or may not apply to other transport. They were interest during the last year for some people to actually look at other transport. Maybe some apply, some not. We don't have that information. We haven't studied other transport than Quick. To give you just a feeling of intermittence, here's an example that we've done with a study we've done with JPL. It's the Earth and Mars communication windows. It has been presented last IETF during the informal meetings. The URL is down in the slide if you want to see more. We took 3 months data set of all the communication windows between Earth and the 4 orbiters around Mars and then the 2 rovers. That's kind of the network you could see on the right side of the slide. And what is shown here on the right is some intermittence patterns. It's not at scale, but the idea here is what is the RTT, right? So, and you could see that sometimes there's a full overlap between all the links, sometimes no overlap, and almost all combinations of overlapping, half overlapping, one after the other. And so you can see you can have a sense of the multiple intermittence patterns that you can see. And that's from real data from the current, it's called Maros project, which is a broker database and software to identify all the windows, communication windows available for missions. Just to give you a sense of it, the best RTT, so we did calculations of the best RTT for each of those patterns, and over the 3 months period, the minimum was 37 minutes. Why? Because essentially at that time, that was a second quarter of 2024 data. And at that time, the round trip, the smallest RTT would be 37 minutes. The average was 16 hours. The question here is don't take too much on the statistical thing in the sense of average, but just to give you a feeling what we're talking about. And the maximum was 7 days, and that's a very special case. We try to find the worst case within the whole data set, and it was Maven, one of the orbiters who has an elliptic orbit, and had to do 2 overpass because one was not working properly. Don't concentrate necessarily on the numbers, but it's more about the actual what we're talking about. Quick in one slide, obviously incomplete, but provide checks on the requirements, such as a reliable transport, which is obviously which is obvious. 1 RTT handshake, including TLS, connection migration. If the client changes IP address, connection continues. You don't need to restart from scratch. You have no context loss. It's done in a 1 RTT handshake, optionally 0 RTT, but zero RTT as some security characteristics, I guess. Stream-based, so for people who are may not be involved in transport, if you have TCP, you usually have multiple TCP connections starting from the three-way handshake to the same server, for example, for different requests or response or things like that. Obviously, for HTTP, we have a better nowadays, but the key point here is you can have a single quick connection, and I often show this as a pipe where you could have multiple requests and response within the connection from different applications between both endpoints, and that connection can stay for a very long time. So that also enables much efficient communications in space. Quick is user space, so easier to upgrade, migrate, adapt, and it's more configurable. Congestion and flow control is probably the most difficult problem, given that we have deep buffers or store and forward in the forward link plane. Congestion is I don't know what I was trying to find the right word, and it's kind of different, right? In the sense that when the forwarder actually stores packet, it's actually not, it's kind of congestion, but not really, right? So I guess my transport peers, experts will say, we'll have a different wording. I'm happy to get the right wording. But if you don't know intermittence, the actual events, as I displayed in a few slides, it's very difficult to have any proactive control, or reactive can be pretty bad in many cases. So for example, an orbiter is currently storing packets because there's no next up reachable. So a source can conclude because of some algorithms or some hints by some congestion control. So it pastes down, but in fact, the next second, the orbiter, which is kind of far from the source, actually has a link up, and then the next up becomes reachable, and it starts forwards the stored packet and whatever incoming packets arrive. But the source is not using the available bandwidth because it pays down, and the time to signal back that, okay, no more quote, quote, congestion, it may be, again, too late because the orbiter could have actually not, no more have the next up reachable. So that means that it's very difficult to manage the congestion as we typically do on internet. Because, and obviously the RTT and the BDP bandwidth delay product are very different. And the bandwidth usage is very important in space, is very precious. So the proposal here is to have what I call a simple profile. So the congestion control is roughly off. Flow control is used only under certain conditions. And transport configuration is based on calculation of the worst conditions. So the longest delay. And the transport is essentially unaware of intermittence. It just sees variations of delays. An advanced profile, which we didn't work on, would be by some means that the intermittence periods and delays are known to the endpoints, and optimization is based on that knowledge. You decrease pacing just before an intermittence event, for example. That must be made safe even when something unexpected happens, because as the Mara study showed us, sometimes the links are not there when they should be, and therefore the plan window doesn't happen. The current profile document is actually talking about what I describe here as a simple profile. And simulations also are based on that simple profile. Okay, I see a lot of chatting in the chat, but I can't really manage it. So a consideration on timers and values in the draft. Initial RTT, for example, is used to start the submission of RTT, typically default to a few hundred milliseconds, should be set in relation to the longest delay. Maximum idle timeout used to terminate the connection if no activity. That should be also in relation to the longest delay. Initial max data and stream max data should be somewhat in relation with the BDP. Window size should be somewhat relation with BDP, but given deep buffers. Patent queue discovery might underuse bandwidth at the beginning. That's the patent discovery within Quick. Since PathMTU well known in space and links do not change much, we might want to turn off PathMTU discovery. And obviously, all those are discussed in the draft with, pros and cons and what, you should be careful about. We also, by studying one of the Quick implementation, we also saw sometimes they send frames and create a packet right away. And even if you would have waited just a bit, you could have multiple frames within quick frames within a single IP packet. And so I guess there's pros and cons and trade-offs about, and given that in space, the bandwidth and the time is limited, you may want to look into having more frames into packets. Last slide, we have done simulations. I cannot talk about them, but we have the Quinn workbench, which is using the Quinn stack, which creates a whole network topology with JSON files as the description of the topology, as a JSON file for events, and then we create simulations. You have a URL at the bottom. Tourist, in the interest of time, that's it for me. I guess we should have some time later to discuss quick simulations. Thank you for your attention.
Should we start the queue or? I had a quick clarification question a few slides back. What's the problem about flow control? Because flow control is meant to not overload the receiver. So that shouldn't be anyhow connected to the network path.
There's no problem of flow control. It's just that for example, in Moon scenarios, and that's where Moon versus Mars is different. Moon, the delay is very short. So where in Mars, it could, as you see in the initial slides, it could be very long. So it's not that there's a problem. You need to be careful about how you use it, I think.
So yeah, you should set it to a big value, but you cannot set it to a value that the receiver cannot handle. Then just the system breaks. So I think you still need it.
Sure, of course. Yes, I agree.
Lysek at Mozilla. Hi, Mark. So I think this is a good starting point, I think. But also, unfortunately, I think there's significantly more nuance to almost all of the bullets you had on your slides. So I just saw so every single of those parameters, I think we can have like hour-long discussions on what it actually means to change it and whether you can do so. So So we got some work ahead of us, right? So I think it's good that we started. It's good that there's simulation. We definitely need to know more about what simulation parameters were and what they actually resulted in, because I'm pretty sure we're going to have improvements that can be made there as well. But this is going to take time, right? So I want to sort of
Sure.
This is sort of still has a little bit of the buff feeling to it, where you want to convince the people that it's like done and solvable, and this is going to take work, and it's going to take time. So I think we need to figure out how we're going to slice that orange or whatever the fruit is to eat here.
I agree, Lars, that
dragon fruit. I hear this is a very fitting fruit for this.
Yeah. I agree, Lars, that there's more work to do on this, and I didn't have any intention of, selling it. I was just presenting what the current state is. I like the fact that you're saying it's a good start, and I completely agree. There's more work to do and more text and stuff, and I'm happy to receive contributions or co-authors from people to help us out. I agree totally with what you said.
Yeah, I think the writing of the text isn't the biggest problem here, right? I think it's really people actually simulating this in detail and discussing the results, and then I don't think this is work that can necessarily occur in a working group. It's not going to be high bandwidth enough. I think there needs to be research groups or the engineering groups out there that do this work and come here to present and to compare their notes with others in the space.
Yep.
Because I mean, so if, like, for example, the quick working group and the web quick people, right? I don't think have the engineering cycles to like work on this, right? Because it's not making, like, I work for Mozilla, right? When Tony already said, right, it's not going to be web browsing in space. That means there's probably not going to be Firefox in space, which makes it hard for my management to dedicate my time to this problem, right? As much as I'm personally interested in it, right? So somebody with the engineering budget that's interested in getting the algorithms developed needs to put the money in and the engineering in.
Sure.
Hi, Mark. Thank you for the presentation. This is Pavel from IETF. So, since Quick integrates TLS for security, how would you address, key management and reestablishment challenges in long duration space missions, for example, the ones that take days and weeks, like, where connectivity won't be available for long periods of time. So do you think there are any strategies in place to ensure secure connections without excessive handshake overhead?
Good question. There's not much text in the draft about TLS key and shake. My understanding of key and shake in TLS, quick TLS, is that it's based on the calculation depending on the algorithm you're using, key length and other, packet size and other parameters. This calculation is actually a number of packets that should be as the maximum number of packets you should be using for the key. So therefore you should make sure that you do the key exchange before reaching that number of packets. So therefore it's not related to time, but more in terms of the number of packets. So and our current solution seems to be doing we haven't seen any problems with TLS. I'm not saying there isn't. But it seems that the current TLS key exchange is actually well suited for space because it's not related to time, but the number of packets.
Thanks, Mark.
Okay, Eric Vink. Pretty much like Lars, I think this working group should not spend too much time doing simulation, but getting the result of simulation done by other people. That's simply my only remark there.
Agree.
All right, thanks. Benjamin, you'll be next. Thanks, Mark.
Thank you. Okay, excellent. Well, thank you very much. Can everybody hear me? I'm hoping, there we go, thank you. I'm hoping with a yes. Okay, so first I guess I wanted to, thank Pavel for the question, because that kind of motivates this presentation that we're about to produce. So g'day, my name is Benjamin Dowling. I'm a senior lecturer at King's College London, and this presentation is based on work with Britta Hale at MPS and our PhD students, Bhagia and Season. So in this talk, we will be talking about the QUIC protocol. So just as a high-level refresher, QUIC is a secure channel establishment protocol, and it operates as two sub-protocols, a handshake protocol and a record layer protocol. The way that it works is we have our handshake protocol, which is executed between a client and a server, and this is used to establish keys for encrypting messages between the two parties. So during this handshake, we negotiate parameters. This is things like cipher suites, key length, what algorithms you will use, and then you exchange Diffie-Hellman values, and you use those to establish some sort of secret keying material. This is then pushed to the record layer, which is actually used to encrypt payload data, and we can see how the payload data is encrypted on the right-hand side here. Okay, so let's move on to the limitations of our setting. So the terrestrial internet, as we know, operates under certain types of assumptions. And as the presentations previously just stated, these assumptions are violated in interplanetary communication. So we can see here that we may have a lack of availability for some of our nodes at particular points in time. We might have additional latency that's being introduced as a result of extreme distances. We might have heightened probability of packet loss, things like this. And all of these led us to the observation that session establishment protocols can be unreliable within this setting. So this means that the choice of any key exchange mechanism has to be really chosen quite carefully, especially in protocols where any kind of packet loss can incur further delays in key establishment. So here, QUIC's handshake at its core is based on the TLS protocol, specifically TLS 1.3. As the previous presentation by Mark stated, this is broadly a one round trip protocol where the initiator sends a message off to the responder, who sends a response back. And then finally, with that final flow of messages from Alice to Bob, Alice can start using those keys to start encrypting messages. So TLS has a lot of very good properties. It's a very well-studied protocol. It achieves forward secrecy, which means that the compromise of long-term keys don't impact the previous communication security. If Alice or Bob's long-term keys are compromised at time t, all communications before time t are still secure. You can't use those long-term keys to decrypt those messages. In addition, TLS has key updates. Alice and Bob, once they've established some sort of secret, can ratchet forward their secrets in a deterministic way. You take secret at time n, you throw it into HKDF, and that gets you a new, fresh secret. This is useful in the context of long-lived sessions in particular. A long-lived session is one that might span, days, weeks, or years. And the problem with long-lived sessions is that they're going to be hitting the key usage limits that Mark alluded to in the previous presentation. There's only a certain amount of bytes you can encrypt under a certain key while still remaining secure. Key update allows you to ratchet forward your keys and kind of circumnavigate those key safety limit usages. So TLS provides you with a handshake, but as we've observed, TLS actually isn't a great choice for the asynchronous setting. So why is this? QUIC's handshake at its core requires some sort of synchronous communication. Alice has to be able to communicate to Bob, who communicates to Alice, before Alice can use those keys to actually encrypt messages. So Alice and Bob both have to be interactive in order to form this handshake, which might incur delays on how quickly you can actually use those keys to encrypt messages. In addition, while TLS achieves some notions of security, such as perfect forward secrecy, it doesn't achieve strong notions of security that are typically what's the word? Desirable for long-lived sessions, in particular post-compromise security. Once Alice or Bob's keys have been compromised in one of these long-lived sessions, then all future confidentiality is now off the table. You cannot assume that any of the messages sent after that point are secure. And that's because even with this key update mechanism, all of the keys are deterministically derived from the secrets that are established during the handshake. So the TLS handshake itself requires synchronous communication. So this isn't fantastic for an asynchronous environment like interplanetary communication, but we do have this key update. So once we establish these keys, we could just use key update or extended key update to keep refreshing our keys. We can, but it doesn't refresh randomness. Quick's key update is essentially just a ratcheting forward of some secret keys. You take your secret, you throw it into a key derivation function, and that gets you a new secret. So this provides you with perfect forward secrecy and allows you to circumnavigate the key usage limits that we talked about earlier, but this doesn't give you post-compromise security. Once you have secret N, you learn all secrets after that point, N+1, N+2, and can derive all keys similarly. But there is this cool mechanism within Quick called extended key update, and this does provide you with something that looks like post-compromise security. So Quick's extended key update allows you to exchange new Diffie-Hellman values, and this allows you to inject fresh entropy within the secrets that you're maintaining between the two communicating parties. I don't think this has been formally analyzed yet, but the structure of this does look like something that would be able to provide you with post-compromise security. However, as we can see on this diagram on the left here, this requires the initiator to send an extended key update request, and then the responder has to send an extended key update response. So we're back to this scenario where we're requiring synchronous communication. And so all of these observations were leading us to the idea that, like, okay, maybe this isn't the correct protocol to use because of this requirement or this reliance on synchronous communication. But Quick has a zero RTT mechanism. A zero RTT mechanism might be able to provide us with something that allows us to get away from synchronous communication. So one potential solution to this problem is zero RTT. The idea here is that both Alice and Bob share a pre-shared key, and then Alice can use that pre-shared key to derive encryption keys that she can use to encrypt messages directly to Bob without a message coming back from Bob. So we no longer require synchronous communication. Bob doesn't have to respond in order for Alice to be able to communicate. But zero RTT in TLS has some serious downfalls. It doesn't provide you with inherent replay protection. It is very much left up to the application to make these sorts of protection decisions in order to prevent this encryption message from Alice being replayed to Bob many times over. And in addition, while TLS handshakes give you perfect forward secrecy, TLS zero RTT handshakes do not. Once the pre-shared key is leaked, all messages that were using that pre-shared key are also known. And so we also know that, like, when we're considering the post-quantum transition, Quick handshake is going to get a lot worse in terms of performance and in terms of bandwidth. Making Quick quantum resistant will incur considerable session establishment costs in the handshake because you're using chems and you're using digital signatures to authenticate and to establish new secrets. And so all of these observations led us to the question, is Quick the correct protocol here? So Quick requires synchronous communication in order to establish secret keys. It doesn't really recover well from packet loss. It doesn't have post-compromise security, which is kind of desirable for long-lived sessions. And all of these properties led us to led us to the observation that continuous key agreement might be the correct protocol here. So continuous key agreement is similar to a session handshake, in which multiple parties are able to communicate and establish keys. The difference between a continuous key agreement is that you're continually generating keys over a long-lived session. So it kind of aligns well with this, with the setting that we're discussing today. But TLS, and therefore Quick, are not continuous key agreement protocols. They are session-based protocols. So what do I mean by this? I mean that Alice and Bob establish a handshake, and then they use those keys for a certain period when they tear down that communication and then establish a new handshake message. The analysis of TLS within academic circles focus on their per session guarantees. Composing a TLS handshake with a long-lived session is analyzed, but the guarantees are broadly session-oriented. We don't consider what happens to the security of the session once the session keys are compromised. The thought is that this basically destroys all security within the session. So trying to change Quick into a CKA requires a new analysis under a new type of model, and it would also require us to reinvent the wheel. So we've seen in the previous presentations that we want things that have been already previously established, reuse protocols that already exist, and then this led us to messaging layer security, RFC 9420. So MLS, I'm not going to give a full presentation on MLS because it's quite a complex protocol, but broadly, MLS is a secure continuous key agreement protocol. So it matches the setting in which we're discussing today. It is asynchronous, which means that the parties can update their shared secrets in a unidirectional way. Alice can update her state and then send that to Bob, and then use the updated state immediately to start encrypting messages to Bob. Sessions here are long-lasting, which means that the models that we use for analyzing these protocols are considering the possibility of key compromise during that period and how it impacts the security of these protocols. And it gets us the security guarantees that we were discussing before, end-to-end authenticity and confidentiality, even against an adversary that controls the entire network and can corrupt some of our secret keys. And this provides us with our strong notions of security, of forward secrecy and post-compromise security. I don't have a lot of time, so I won't get over this, but the core idea is that MLS is structured as a series of epochs, and each one of these epochs is incremented when one of the parties does a key update in a unidirectional way. We generate some fresh entropy, this KI, KI plus 1, KI plus 2, and we inject that into our shared secret state, and we use that to ratchet forward, providing us perfect forward secrecy, and the fresh entropy that's being continually injected into our secret state is giving us post-compromise security. This is a very simplistic look at how MLS operates, but it should give you an idea as to how CKAs operate. Okay, so our proposal is to implement MLS within Quick. So this is to take advantage of the work that has already been done to fit Quick within this setting. And the idea is to replace the Quick handshake with MLS updates instead. So this would help us to now achieve post-compromise security and asynchronous updates. Okay. And so this kind of gives you some idea as to how we see this working within the stack, where we have our MLS messages that are going inside the Quick protocol logic, and we have the output traffic secrets or the key updates that are coming from the MLS handshake. Sorry, the not key updates, the actual keys that are coming from the MLS handshake, and these are being injected into the record layer for use for actually encrypting messages between the communicating parties. We also had a proof of concept, which was done by our PhD student Bagia. So this was developed using the Quick Go and Go MLS libraries. And so this is a proof of concept. So this is two parties communicating to establish keys and then to update those keys. And the point that I want to draw us to is the fact that the MLS handshake is on the same order of magnitude as a TLS handshake. So we're not introducing significantly much more complexity over the top of what TLS was already doing. Okay, and on the right-hand side here, we kind of see how this is expected to work in practice, where we form an MLS group on the top half of this diagram, and in the second half, Alice wants to update her keying state in order to inject some new entropy, achieve post-compromise security. So she generates a new key package consisting of an update, a commit, and some fresh state. She sends the update and commit to Bob, who then updates to match Alice's new secret state, and the secure channel continues under this new epoch. Okay, so to kind of wrap up what I was talking about, so the core idea here is to replace the Quick handshake with an MLS handshake, with the Quick record layer remaining completely the same. And the hope is that this would allow us to achieve quick adoption with MLS security. And so what we're asking the working group is the working group interested in this approach? And if so, the next steps would be that we coordinate with the Quick Working Group. We take this proposal to the Quick Working Group for draft and adoption to create a Quick MLS extension, and then we return with that Quick MLS extension to the TIPTOP group for adoption. And that's me. Thank you very much.
Okay, before I just want to know something. Like, do you aware of this TLS working on this extended key update? TLS
Sorry, say that again.
on extended key update for TLS. Do you aware of that one?
No, I'm aware of it being within the Quick Working Group. I'm not aware of it within the TLS Working Group.
Okay, so yeah, I would suggest like you have a look into that. But let's listen to them.
Hi, Lars Eckert, Mozilla. Do you think this is sort of the largest issue that precludes Quick from being used in space? The handshake.
So I guess this is kind of trying to address like two drawbacks, I think, with using Quick as this approach. So the first one is using Quick with long-lived secrets, i.e. without doing like a handshake continuously, incurs the security drawbacks, right? Which is that like you can't recover from secret key compromise.
So I got that from your talk, but the thing is that there's a list of things that the working group needs to work on to get Quick useful in space. I'm kind of wondering if so we got to prioritize somehow. And so I'm wondering if in your view, this is the thing we need to prioritize now.
I think that if we want to prioritize security with interplanetary communication, then you need to address like how does this handshake actually work in practice? Yes.
As a co-author on this, I'll just weigh into that question as well. That obviously, eventually, as we work through all the other aspects, if we don't do something about this now, and of course coordinate with Quick Working Group, we'll get to an end state that is not going to be secure in the setting, and then we'll either be held up or forced to continue with that current end state. And so it is probably a priority now so that we can get the ball rolling.
Thanks, Ben.
Maria?
Yeah, Kuhlewin. So this is a significant change to the Quick protocol. I think that needs to be done in the Quick Working Group if you would do it. And I think that's also what
yes.
the
So I completely agree with you. So the objective here is to determine the interest in this as a core approach that we would take to the Quick Working Group.
Yeah, I think that's true. I realized like in Quick Working Group there was a presentation in this IETF meeting about Quick extended key update. So they want to do it, and this is coming from the TLS extended key update that actually solves some of the issues that we have been listed here. So have a look at that one. And obviously, I mean, I don't think like I also agree like this is a serious change on Quick protocol, and that should be done somewhere else. What I like about this one is like the asynchronous part that you have talked about, because this would be really important factor for the space use cases, right? So I don't think like we're gonna ask for anything right now. It's just like, as I say, like talk with. You can contact with the Quick chairs to talk about that one. Look at the TLS key, extended key update, and maybe come back and report.
Should just be sure that I understand the process correctly. I think this working group could say, you know, we have a problem that needs solving, but you actually need to go to Quick to figure out what's the right solution to the problem.
Right, that's the right thing, yes. Because I think this working group, we are not chartered to change the protocols, right? So if anything needed to change a protocol to be worked in this space, that need to be done at that working group. So we need to do that. But as I say, like go and talk with them. I think there are some issues that has been already tackled by this TLS extended key update. Think about it, and maybe you can come back and report. But mostly, if anything
yes,
needs to be
so
done,
just one last thing to mention is that the extended key update is still requires synchronous communication, right? It doesn't solve kind of like the core issue of we're working with an asynchronous environment here.
Yeah, I mean, could be. Yeah. I just wanted
So-
to, you have to look at it. Britta.
Clarification there. Yes, we have, I mean, there's various members to this group, and yes, it has been looked at. That, as been already noted, is already synchronous still. And more particularly, it was designed out sort of as a patch to the TLS version for extended use, so to speak. That's the original intent. It was never intended as the sort of pro-norm version of using it, and it's never been analyzed, therefore, in this sort of continuous context. It would
Hey,
require a
Yvonne.
fundamental reanalysis. I did have a point before we close out. I know we're at the end of time, but a point before we close out, a question for the chairs. Because it is part of the working group charter that the chairs between the TIPTOP working group and any other working groups will coordinate if there's needed work in other working groups. So we are very happy to take this to Quick. That was the whole intent of bringing this up. But it's a matter of whether this is actually a working group aspect that the chairs are leading to making sure that any coordination happens, or if this is simply a push to the side. So over.
Hey, Britta, I'm sorry. I'm going to have to cut it short and play the timekeeper here because there's only 5 minutes left. I don't think we will be able to get the question and answers here, but I would encourage everyone to actually send it on the alias, and we can always have a broader discussion there.
So I think we're trying to set up a new working group, and one of the things that we would like to set up is like, how do we work? Like, how do you collaborate? How do you create? How do you produce the drafts? And the proposed contribution model, we think would be really good, that we have been doing in lots of different working groups, and it has been working, is like doing things in GitHub. And basically that means like when the work gets adopted, so we create a GitHub organization for us. When this work item, we have a work item, we have a document gets adopted, then you go through that one, you see some issues, you have some questions or clarification or whatnot, you post an issue. It could be anything, from editorial to some design issue or anything. And then basically we discuss that one in GitHub and in mailing list, in the meetings. We create pull requests, and then we actually publish a new version of that draft. So that has been we think like we should do that, but we really would like to have a discussion in the working group, like how the working group would like to go with that, if it is fine or if it is like not fine. So any opinion on that one? Anybody thinks that's a bad idea? That's basically what I'm asking. No? Okay. So that means like we need to work a bit more. If we would like to do things in the GitHub, then we need to. So, yeah, sure. And we should do a poll. I just got reminded. But what I was going to say is like, if we do that, then we need to come up with a workway how to do that, and we'll be working on it. So let's have the poll up. they're saying no. I think votes are settling on, so we can perhaps give it 1 more minute, then we'll close it. The moment I said that more votes are coming in, that's great. I think we can close the poll right now. Okay, for the record, this is like 97 participants, 24 yes, and now I lost it. So 24 yes, 5 no, and 19 no opinion. I would like to hear like those who has voted no, could you clarify like what is the concern so that if we see if we can address that or like.
Hi, Tony Lee. I voted no because there's not necessary. This is a fine mechanism for working on particular documents, but folks working on documents should be free to do whatever they want. We don't need to do everything in a common GitHub just for this.
So I didn't get that. So you said like individual document they can do however they like? Yes.
Okay.
We're talking about working group adopted documents.
So why do we have to have it in a common GitHub, even if it's a working group adopted document?
That's what we are trying to see, like we want to go for that model or not, because it's more collaborative. We have been trying it in IETF for a couple of years now, and we have been
That seems
pretty
unnecessarily
good at that.
restrictive. It's perfectly acceptable and reasonable to do work in a private repository, even for a working group adopted document.
Anybody else want to know? Want to say, share their thoughts? Yeah, Mark, yes. Go ahead.
Well, two things. One is similar to Tony in the sense that the actual process, IETF process, doesn't rely on GitHub. So I think we should not, change the process. I'm fine with, doing issues and pull requests and stuff. We actually have been doing this for all the drafts, at least that I'm involved with. I had some issues with another draft on another working group with some people from some countries having problems accessing GitHub. And this creates a lot of issues because, for the flow of work between the co-authors, it becomes very difficult. And the last point I would like to make is it seems that the merger of PRs to be under chair supervision seems to be a bit more too much of detailed control. We want to have, kind of a easy flow of working. And since everything is being in the clear, and so I don't see a need for chair supervision. So I'm not against that, but I'm not sure we need to be that enforceful for the work of the others in the working group.
Okay, so the under chair supervision, I think this was a bit restrictive. I agree with that one, but that's not the intention. I think like when we'll have a full kind of GitHub workflow, then I think the authors or editors would be using their judgment and the consensus in the working group to do the merge as they like. To begin with, we might actually have some kind of supervision to see like everything is going fine. That's the only thing we want with this under chair supervision things. But as I said, like we need to come up with some kind of like rules how to do it. I don't see anybody on the queue.
That's because you can't join it anymore. Because you're over time.
Yes.
Andy Bush, IJ, and Arcus. You forgot to specify what font must be used.
Okay, we're over time. Thanks for the reminder. I don't think like we have we can conclude it. Right.
Big question. What color is the bike shed roof?
Okay, we'll work on that one.
All right, thanks everyone. Hope to see you on the list.
Thanks, Chair. Sorry, I was joking.